coming in July 2004. Over the years, our soldiers have had to travel on horseback. They've had to travel in vehicles. They've even traveled in helicopters. Now, we don't need cars or horses or helicopters, because our soldiers can fly. Upside down. Now, with the help of mechanically inclined pork and beans, if they eat them every day, our soldiers can fly up to 200 miles without a refueling. We have made stations in space. They are fueled by their own gas. Yes, yes. But a great war has come up between countries, and the soldiers, they crash and they die and fall to it's coming. They fall to their deaths. So this summer, come to the hospital, run to the theaters, but whatever you do, don't fly with a soldier, because you will die.
Hello, my name is Jared Money. When I was younger, I used to make movies. I'd make movies with my friends, filming little stunts, skits, things like that. This evolved alongside my interest in the internet. And sometime in the early 2000s, I discovered a website called filmfights.com. That website, can you all hear me? Okay, great. That website was a bi-weekly film competition in which you got to compete with other creatives online, other people who grew up doing what I was doing. I'm running around with a deteriorating camcorder with the viewfinder hanging off with a built-in fade-in, fade-out button. You grew up messing around with that. You probably discovered film fights, and you discovered other people like yourself. And that meant you got to compete and watch them step up their game. You'd step up yours. Well, that came in many shapes. They bought lighting. I'm saving up all my GameStop paychecks to get some lighting. They had a car chase. I'm getting my buddy a speeding ticket for doing drifts in the middle of a parking lot in broad daylight. True story. They had a website. Well, I'm gonna make a website. How do I make a website? So I dive into the fundamentals. HTML. I have no idea what the HTML any of this is. So, oh, tables. I recognize that. I'm going to use them for everything. This is a menu. These are buttons. You'll notice each button is also a GIF for, of course, performance reasons. It's amazing. Oh, CSS? Great. I'm going to use images everywhere and poop brown and chalk pink as my color scheme. Also, apparently, signing up for Telegram Films gets you a free kick in the head. So, I mean, that's a steal. So that was way back in 2004. I had my website, JavaScript, no thank you. HTML, CSS are on point. Now, how do I get this bad boy online? Oh, it's 20-something odd end years later, and I still don't quite know the answer to that question, but I have managed to do it a couple of times. So again, hello, my name is Jared Money. I'm a software consultant here at Solution Street. That was my foray into web development, and a little younger me would have never guessed that video would reach anyone outside of our living room, nor will it probably after this ever again. So how can the front end be full stack? Mr. Clickbaity title. Well, let's get in some quick fire terms. You guys are some smart folks. You know these things. What's the front end? It's the client side. It's the visuals, the stuff you interact with. You put a VR headset on or you tap your Apple Watch. That's the front end. It's the client side of the thing. The back end, as some politician once famously said, and I believe correctly, is a series of tubes. It's the persistent bit. It's the database. It's all of the information that persists in between ethereal or ephemeral client sessions. And then the full stack is somebody who can work on both, from the button that updates that wants the database to be updated to the database. Any work needs done, they can do that. Cool. Front end, back end, full stack. So how can the front end be full stack then? Asks the very clever audience member. Well, in short, JavaScript. In long, this talk. Keeping pace with web development has been hard. I've been doing it since my teenage years and professionally for 7. JavaScript is a flexible, permissive language that is easy to adopt. Some would call that a foot gun, others would call it an opportunity. The explosion of the web has led to what was originally a scripting language for the browser to become the dominant programming language of the planet in under 25 years. From the front end to the back end to the database that it reads from, the primary code editor of the field, Visual Studio Code, is written in Electron.js, i.e. JavaScript. We write our JavaScript using JavaScript so that it may be served with JavaScript. Well, unless you're using TypeScript. So, how did this happen? Well, what does modern web development look like in a world post JavaScript with 30 plus years? And where is it going from here? Well, Jeff Atwood very concisely put it in 2007 with Atwood's Law. Any application that can be written in JavaScript will eventually be written in JavaScript. And here in 2004, dun 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 dun. I need the doesn't matter. 2024, I believe he has been proven right. So I don't know how many of you made the right life decision and did not get into front end, but I am not among you. So consider me your front end liaison today. Consider me your David Attenborough, just with nowhere near the voice. As we build towards this tech stack, what is this tech stack? This is a tech stack that I've been working with at my current client for the last 4 months. We just recently released an MVP, woohoo, to actual clients. So that's awesome. I want to make it clear that there will be no tests. The tech stack looks like this, but I do not have an interest in teaching you these technologies because you may not be using them, nor would I be the best teacher for them. However, by building up to this list, I believe we will reach our goal and have a sense of the complexity of what a modern web application looks like, how to deploy it, and how we got there and where it might be going. By the end of this talk, I hope that we can explore a small app that I've built for today, that there won't be much confusion going through the app. It is a small create, read, update, delete. It's a CRUD app of a personal interest of mine, but put a pin in that because it's time for my least favorite class, history time. And it's the history of the web, so please sit back, relax, grab your favorite cute dog and a drink. All good stories start, as the web's does, and that's with Al Gore. As we all know, indefatigably, Al Gore created the internet. If anybody tells you otherwise, it's a psyop. Then at some point down the line, Sir Tim Berners-Lee introduces HTML. Total nerd. Nerd. Look at him. No, I'm just joking. He made the first website with HTML, which was, of course, about the web, because we love recursion. He's not a nerd. He is a total Chad. HTML, what is it? It's the structure of the thing. It's the bones. It's the relationship. Server-side scripting comes along. CGI says, hey, Perl and other languages, how about we leverage you to make dynamic responses? What if somebody does something on the web on the front end, and instead of sending them a whole templated page meant for this purpose, we can dynamically create that whole page. It's still static on the front end, but man, that would be really cool. And that's what we see in 1993. The World Wide Web Consortium appears in 1994, formed at MIT, also known as the Consortium of Nerds. Tim Berners-Lee is also integral in the development there. He's going to be popping up a couple of times, and the World Wide Web Consortium will be as well. In 1995, the hits don't stop coming. This fine chap, Brendan Eich, sits down for 10 days at Netscape and says, I'm going to create JavaScript. Great success, no complaints. So what is JavaScript? If HTML is the bones, JavaScript would be the muscles, the action of the thing. It allows the structured DOM to do things that it wasn't originally structured in, among other pieces of functionality. You can update the DOM. So. And in the very next year, the World Wide Web Consortium releases CSS. I would argue upon the world, and my wife says the comparison broke down here. However, we're going to stick with it. If the skeleton is the HTML and the muscles, you know, see this where this is going. If the muscles are the CSS, then the HTML is, sorry. If the HTML are the bones and the JavaScript is the muscle, then the CSS is the skin, the nasty, sweaty skin that just is always there, that we have to deal with. I think that's how developers feel about CSS. It's always there. Really, it can be more frustrating than it's worth some of the time. Yeah, okay. It's enough thinking about skin. CSS. ECMAScript standardization. Turns out JavaScript was a good idea. And people tend to take good ideas and say, that was your idea? This is my idea. It's kind of the nature of code. You fork off, you make your own changes. It's great. However, when you're looking to create a programming language from the web, having a bunch of different companies vying for, amongst other things, their version of JavaScript to quote unquote win, it can lead to fragmentation and serious issues for development. So Netscape and Microsoft find themselves ding, 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 in the fight of their lives, competing for dominance. We know ultimately who won. But the end result is JavaScript does get standardized under ECMAScript 1.0. Netscape and Brendan Eich's proposal did end up winning. However, Microsoft won the war. Also, on the back end, 1997 didn't want to be overshadowed. PHP hits 1% usage. What does this mean? That's a tiny number. Who's impressed by that? Well, it is a server-side language. It is a language built specifically for the server. That is a powerful notion. 60,000 servers report having PHP installed. Things are about to get a lot more dynamic, as one of the main features of PHP is that it can inject, instead of a whole page, it can take a template, an HTML templated page, and just update the pieces that need to be. So we have hints of where the web will be headed. And not to be outdone, the front end finally gets the support for embedded isolated content, i.e. separate from its parent page. Dynamic resources are enabled. You can call now other servers inside of the page you exist in from your initial server call to get third-party resources. It hints at a dynamic future on the front end. So let's take stock. Where are we? Well, the web looks like this. Better remember that. I mean, these are the golden oldies. Come on, come on. You can't see a history of the web talk without seeing these slides. I have to. This is what the web looked and felt like. It was stable. It was relatively quick. We weren't asking much of it. And it was being adopted vigorously. However, it was static. The server gets a request, it fulfills it. You want new content? You make a new request and you refresh the page. The idea of a like button is a twinkle in the eye of some young Mark Zuckerberg off making some poor middle school just that much more awkward. The place is a web to get information, not really to interact with it. That's until Web 2.0 comes in the early 2000s, kicks the door and then says, hey, check it out. We got this thing called Ajax. Now, it's not actually a individual concept, but that's what it becomes known as. Dynamic content becomes mainstream. What does that mean? Gmail, Google Maps, Outlook, they are now integral to your grandmother's happiness. JavaScript means that your grandmother does or does not get photos of her grandson's birthday party, or that awesome mayonnaise cake recipe that her friend swears is not going to be awful. XML HTTP request is at the center of this. It's developed by Microsoft, but again, those wonderful chads, the World Wide Web Consortium, step in and standardize it. And as a side effect of all of this innovation, bringing dynamic content and making it easier to do, there's of course a trade-off. We have a hard time now guaranteeing the state of a user. Now, we've been managing the state of the user in the back end for a number of years at this point. But the front end, we've got cookies, local session hasn't come out yet, local storage. But the state, much like a full-fledged app, we are watching websites become web apps. And this is one of the quick little pokes. It's like, okay, it's kind of becoming a pain. Now, speaking of pains, social media and layout explosions. Who remembers this? Facebook 04, YouTube 05, Twitter 06, iPhone, oh man, iPhone 07. That's also the day the war on Flash occurred. talk about a lot of new complexity for the front end. Complexity of the web has increased. We're asking more of it more often from more varied devices. So what happens? When there's a rise in complexity, devs do what devs are going to do. They're going to dev, and they're going to make libraries that address complexities like cross-browser compatibilities, DOM manipulations, AJAX simplification. AJAX may be a wonderful thing, but it doesn't mean it can't be easier. Libraries like jQuery, MooTools, handlebars, all of these things start hinting at what we'll be talking about here shortly. The libraries rise as a response to the rise in complexities, but the complexities continue to grow. JavaScript continues to take on a larger role. So, enough broad history lesson. Let's focus on what's important here, and it's me. Hi, I'm Jared Money. I'm a full stack developer, but I didn't start that way. I'd like to tell you, this is a tale of a man and server, and how they got to know one another really well, and were able to share with the world what they create. But that is not the case. Let's rewind the tape. That first website I built, that brown, pink, wonderful little monster. I'd love to tell you that I learned PHP and I learned all the latest and greatest tech. I gave my buddy $25 because he knew how to do a web host. He bought the domain, and a weekend later, my website was up and I could show all my friends. That was the extent of my back-end experience for a while. I got into video making and got into ActionScript, of all things. Turns out JavaScript, of the holy trinity that I was looking at the very beginning, JavaScript was the one that would have hooked me. So a lot of what I did was for personal use, a lot of video work. My backend for a long time was YouTube. I would make videos for a client, I'd upload it. I'd use YouTube as my platform, and WordPress as a tiny front end if they needed something to put it on. I would tinker locally. Who remembers the lamp stack, the WAMP stack, the XAMPP stacks, the Jam stacks? I also dabbled when I came back in 2016. I dabbled with a number of different front ends, landed on React, and I got into Express, and I had local backends. But you'll hear a theme. None of this was in production. None of this. All of my production work, all of the work that I'd sold to individuals, my clients, all the work that I could point at was front end and visual. That was until node.js hits the scene. Node.js, created by Ryan Dahl, was a response of Google's V8. Just-in-time compilation means that it's no longer an interpreted language. What does that mean? On the browser, JavaScript was slow, is inefficient, and it had browser-specific engines. Whatever you wrote, it was run line by line. It was interpreted. That means the larger your application, the slower your app was, just by the nature of how it was run. But with just-in-time compilation, that was no longer the case. It was open source, written in C++, which means it was blazingly fast. It was efficient. It was portable. It means you can now have JavaScript no longer just in the browser. It's a powerful concept. It allowed for more complex code on more devices. Again, the role of JavaScript just continues to expand, and my life is becoming increasingly attached to it. You can add event-driven non-blocking I/O, which Ryan did. What does that mean? It means we get the asynchronous and scalable capabilities that C++ provides. The node package manager becomes a necessity, as there's a lot of devs that use JavaScript, and a lot of devs are going to want to use Node, and a lot of devs are going to want to contribute. As a package manager for JavaScript, it quickly becomes the largest software registry in the world. And Node modules, which is where all your libraries that you download from it end up, is subsequently the heaviest object in the universe. Drink break. Speaking of node modules and where they all end up, I promise we're getting to the nitty-gritty, the good stuff, modern times. Frameworks and single-page applications. We had handlebars, we had jQuery, we had these attempts at solutions when Google came in and said, hey, you can make the entire back end JavaScript. We're going to do that for the front end. Hold my Red Bull and check this out. And they introduced to the world AngularJS, made by Google, introduces the concept of a single page application. And why single page applications? Well, I'm convinced it's because we could. However, there does seemingly be, it's seemingly some reasons. As we've mentioned, the web and websites are now web apps. They are data-driven, they're stateful, they're dynamic. There's a lot going on. This is intentional. Google wants a rich desktop-like experience in their applications. And they also want to reduce the server load. Right now, we're not leveraging the clients nearly as much as we could be. People are walking around with supercomputers in their pockets. Why do we have our server farms performing most of this computation? We could just pass some of that on to them. And that's exactly what they do with SPA. It is literally a single JavaScript bundle in a single HTML file. That's why if you go and inspect the source of any website that was built this way, it is just an HTML page with a script tag. You can add other things, but that is at the heart of what a SPA is. It is just JavaScript. As a result of this, SEO is hard. Why? Well, because it's just JavaScript. Web crawlers need a web to crawl. And if nothing is, if no pages exist until a client is browsing it and gets it into that state, there's no information to grab. However, the JavaScript domination is now complete. We used to have servers that had file structures, right? You have a folder, you have a file, and that's where http.com/website.com// those are literal folders on a server somewhere. It has come so far that we now emulate that with routing solutions. We have completely replaced the need for it, but we're not going to ask every person who's ever used a website to adjust their frame set, their frame of mind on how to do that. So we just have JavaScript just recreate it. Oh my, hello, oh, hello, Mr. Zuckerberg, how are you? Been hitting the gym, I see, since your middle school days. Fun fact, I did not tell it to make him this muscular. I said, Mark Zuckerberg handing me a plexiglass check mark. And the AI was just like, and he's jacked. So there you go. Go to sleep with that in your head tonight. The tech stack. Looks like we made it to our first one, React.js. In a response to Angular, Facebook releases a component-based library called React. They're dealing with a lot of data. What does that mean? Well, it's component-based. It's not a new concept, but they heavily push it. It's built around it. Discrete, reusable pieces of UI. Just ship the view layer. Don't provide any routing. Don't provide any state management. Don't provide any data fetching. Just a solid, performant UI layer. And then they can bring the rest of whatever they want with them. They also introduced the world to JSX. It's HTML, but it's not. It looks like HTML, acts like HTML, but ultimately compiles to JavaScript. I've got some very complicated code examples here for you. On the left, it's JSX. On the right is On the right is JSX. Actually, I'm not convinced either of these are HTML anymore. These are both HTML and both JSX. That's kind of the point. Not all examples are one-to-one, but that was the goal. So now all of your HTML, it's JavaScript too. They also introduced the idea of the virtual DOM. Turns out manipulating the DOM, as mentioned earlier, is expensive. And not everybody's devices are super powerful. So how best to do that? We need a lightweight in-memory representation. And that's exactly what they built. The virtual DOM allows for a diffing algorithm to update the real DOM. Basically, all that looks like is you have an event, you have something to react.js to. That is then compiled into a bundle that is compared against the virtual DOM. The virtual DOM is then used to derive what are the minimal amount of changes to affect the minimal amount of components, and data representing real DOM elements, to push that update to the user. So the virtual DOM is like a middleman, that not even like, it is a middleman that allows you to derive what the best course of action is before performing it. And it's a powerful notion. Now we're just knocking out of the park, aren't we? I don't quite know what happened before this photo, but 1-2 punch. React in the front end, GraphQL in the back end. Facebook again dealing with a lot of data. They created a query language for APIs. What does that mean? Well, it's declarative data. It's what data you want with no over or under fetching. It's not a query language for the database. It is a query language for the API. It's a big mindset shift. Instead of giving a list of API endpoints that you can hit to get data, and it comes back in whatever shape some team decided 6 months ago is the shape you're going to get it in. And the endpoints are all laid out exactly how. Oh, and you need a new endpoint? Well, first of all, we're going to have 3 meetings. We have to talk to 2 separate teams. And we're probably going to have a couple of spikes on that. And then we'll get back together with a sync sometime in December. With GraphQL, you get what you want when you want it by shaping your request how you want the response. It also is strongly typed, which will work very well with something I think we'll be talking about here soon. And it benefits from a single endpoint. So instead of having that aforementioned list of resources, you have one endpoint that is flexible and can be updated to the front end's needs. Whatever data you want and nothing else. It's powerful. You can see why a company like Facebook would be interested in this. Oh, hello, Steve Urkel, Bill Gates. At least I think that's who you're. Hi. I would like that check mark. Thank you. I think that's a check mark. I don't quite know what that is. TypeScript. We just talked about types. I'll get through this quick. It's developed by Microsoft. JavaScript is a dynamically typed language. That means if you have a variable called username and it's a string called Jared, some point down the line, you want to make it an object, and that object has 1,000 keys. Each key is another object, and inside those objects, each key is an array of 1,000 names. You can also just call that username. You can see how that might be frustrating. It adds static typing to the development process of JavaScript, something that makes all of the real devs happy. So let's take stock. It's 2015. The Force Awakens, roaring into theaters, in my opinion, setting our expectations way too high. And Uptown Funk is keeping us all entertained. Also, these guys. Give me 5 seconds there. If you haven't seen the black and chrome version of Fury Road, highly recommend it. This is an age of innovation and change. This is an age of social media. This is an age in which the web is finally coming into its own. Web 1.0 is a bad memory. And the web is now a place where real people get real stuff done in real time. Really. It's integral to our lives. We're all grandmas now. And the web isn't a tool or a platform. It's now being discussed as a human right. The internet is a necessity for how modern first world life operates. And at the heart of all of this is JavaScript. It is the most popular language in the world, and the jokes of a new JavaScript framework every day are not far from the truth. These modern web apps are complex, and so too are the tooling. But everything is a process of discovery, of ebb and flow, of innovation and change. The web is a constant place of change, and it will only be getting faster. I personally can't wait to see what's next. JS. You thought we were done with the boring graphs? Actually, wait, I got one more for you. Vercel. Who's that handsome devil? That's Guillermo Rauch. Guillermo Rauch is the inventor of Vercel. Why did he invent it? Well, there's a lot of people like me who are very well versed in building fully fledged websites. However, these websites are quite difficult to get online. It's kind of like what I started the talk with. What is the best way to get a web app on the internet? Turns out it's not that simple. So they provide a global CDN. They provide which can compete with Amazon. That was like, I knew there was a big facet I was forgetting. What makes it difficult? I don't know about you guys, but I have a little React app. It's not even that dynamic. I just want to put it up on the web. I want to just buy a domain and a little bit of space and just put it somewhere. And I don't want to deal with the rest of it. And then you go to Amazon Web Services and you just see the wall of hieroglyphs and your brain and eyes just kind of glaze over. Yes, I can set up an EC2 instance. Yes, I can set up a bucket. Do I want to? No, I don't want to do any of this stuff. I don't want to scale anything. This is all, for me, a nightmare. Just another thing to learn. And they saw that as rightfully an opportunity. And they provided a framework-specific deployment platform with global CDNs that compete with Amazon, edge functions. So now you have serverless functionality right on the edge of these networks, and a heavy, heavy, heavy focus on developer experience, I think, led to Vercel exploding like they did. They were used by GitHub, Airbnb, and Uber, really showing their scalability. And it's just, the world's basically been their oyster since then. So what is Next.js? Well, if you're a framework deployment platform, it would behoove you to have your own framework. It's a framework for React. So earlier, React is bring your own solutions, and that works for a number of things. One of the major pain points in the React community was routing. One of the major solutions is React Router, but go look at React Router v2, v3, v4, v5, and tell me how much of it stayed consistent. Go look at its competitors and tell me the same. Next.js brought the concept of, and it had been explored in other libraries, folder-based routing. However you set up your folders under a special under a special folder called Pages, however you set it up, that was the directory of your website. It sounds a lot like how servers used to be, but now my backend is one folder above all of my front-end stuff. But of course, because JavaScript. They also introduce natively, as a first-class citizen, server-side rendering. If you don't have any dynamic content, well, hey, we can just render your React app on the server. Brilliant, right? Because then it's SEO friendly. And we stop leveraging all those clients. Those clients have been having large packages for so long. Why don't we use the servers? And the servers say, wait, what? This feels really familiar. But it saves a lot of computation and is ultimately better for the user. In 2018, they really go ham and they introduce API routes. We will show that here in a bit. Long story short, you want to make an API route, like what we've discussed in the past, a route for you to hit from the front end, you can just now do that directly above your pages directory. You now have an API directory. And directly below your pages, you have components. All written in JavaScript, all in Vim, a couple J and Ks up and down. Serverless functions. I don't think that bullet point was supposed to be there. Anyway, React 18 brings along server components. We'll get to that here in a bit. That was a lot. We've come a long way. I don't know about you guys, but those 25, 30 something years, they went by pretty fast. I'm feeling a little flabby. I might need to skip Christmas this year. I think some of the last ones didn't come off. If you remember way back before Al Gore, I mentioned a small app that I built for the purpose of today, to see all this come together, to experience what modern web development could look like. So let's talk about that. This is a comic book. One of my favorite comic books, one of my favorite comic book artists. This is Scotty Young. Scotty Young is, he has a very distinct style, and this is one of his, I would argue, iconic covers. I even have this in a small figurine. Here is that same comic in a graded slab. This is called a 9.8 grade. This company, CGC, they provide a grading service and a slabbing service, and they capture details about the comic book, including, in this case, its signature, hence the yellow label. these are my comic slabs. I also, yeah, why, yes, my marriage is going well. Why do you ask? I don't, it's a weird question. So I wanted to build an app to allow for tracking of these slabs. And I felt like this was a wonderful reason to do so. So without further ado, let me get out of the slides here, go to my desktop, make sure, see if this works. Come on, I believe in me. I'm assuming you all can see. Cool. So this is the MVP of the MVP of the MVP of SlabTrack. This is an app where I can track my slabs. So this website is the cgc.com official certification number lookup service. So my goal was to take their data and to bring it over to my application. I had no real interest in the photos or any of this other stuff, but I did want to capture such as the grade, the issue, the variant, key comments, etc. I can add a new slab. There's already one built in. There we go. Oops, go back. Here's all that content that we just saw on the CGC website, brought in for the slab, ready to be put into the database. Here I can put in my extra information, such as my purchase price, asking price, purchase platform, etc. I can submit it. I get notified it was saved successfully. If I try to add the same slab, it does a uniqueness check, as you know, any self-respecting database does. Speaking of, let's take a look at the code. I was using my code editor to, oh, look, here we are, demo of app and code. Show this file and say hi to past me. Hi, past Jared. Thank you for all of your help. Oh, great, thank you. And it is, I appreciate it. So let's show the React components. So if we head over here, we have not a lot of components in this app, but you'll see things such as button, dialog, input, label. We can hop into each of these. These are actually provided by a third-party library that I'm leveraging. I did not have to style a lot of this app, but you'll see the concept of CGC data, fields to display. Again, this is very much MVP of an MVP. These are small pieces of UI. This is just the review form. If we head over to the search field, there's a bit of functionality here for handling the steps, for handling the submit. I don't want to go through all of this step by step, but I did want to give a feel of what modern web development looks like. So let's say we head over to get CGC data, which is being called by the fetch CGC data by certification number function. If we head to the API folder, get CGC data, we can actually see, modify, and do anything we want to this backend. So what is happening? Well, this is the backend that is reaching out to, because I would have gotten a CORS slap on the wrist here if I had tried to fetch out data from a third-party website from the front end. Obviously, you just shouldn't do that. So here we have the CGC URL, fetching the CGC page content, for passing in the cert number. Cheerio is a web scraping app. It is a headless browser, so there's no visual layer. You just get back the raw HTML, etc. So I'm grabbing that data. I'm then grabbing the slab data from that information, from the page content. I'm then getting individual DOM elements. I'm extracting the content from those DOM elements, et cetera, et cetera, et cetera. You get the idea. And then I'm sending back all that information to the front end for review by the user. You'll also see similar API endpoints here for adding slabs, removing slabs, et cetera. So let's take a look at what a mutation looks like, or let's take a look at, where is it? So in GraphQL, there's a query and there's a mutation. I know I use a query somewhere, but it's currently eluding me as to where that is. So regardless, this can also say query, which indicates your intent to the GraphQL API. Speaking of that, and that was my segue, let's take a look at it. we have not actually gotten there yet, and I have a slide for it. This is Hasura. So you just saw the front end with the components folder, the API folder, with the component speaking to the component, with the component speaking to the API route. The API route then speaks to Hasura. Why did I pick Hasura? Because it is what my client is currently using. I wanted to mirror their tech stack so I would get more experience with it. And they use Hasura to generate their GraphQL API. What it does, and I have a slide that explains this, but I can do it without it. You provide it, or they provide you a Postgres SQL server. That server then receives a GraphQL API layer that Hasura generates for you. This includes things like what GraphQL uses called resolvers. You send a request to the API endpoint, and it resolves that request based off of the resolvers. It's typically in there where you would write either the raw SQL or speak to your ORM to then speak to your database, update it, etc. What Hasura does is abstracts all that from you. They realize that they could take a database, pull the types from it, they could pull the schema from it, they could create the GraphQL schema, and thereby the API. They could detect all mutations, queries, and subscriptions, and they could generate all of these methods and types and things that you would typically have to go in and do manually for you. There's also third-party tools. One is called GQL Code Generator, I think is what it's called, that is also used in that process to take a schema and to convert it into a bunch of types that TypeScript can leverage. And other tools like Zod, etc., allow you to do that across the whole stack. So here sits all of my data. To show the subscription feature, I'm going to delete a comic book here. Let's see if I can created at, sort by created at. Should be bone number 1 is what we're looking for. Give me just a second. There it is. And if we look at the front end, bone number 1 is there, but I am leveraging a Hasura subscription, which is essentially a WebSocket through GraphQL. So if I come to the back end and I were to delete my comic, row is deleted, I come to the front end, I think we just saw it, just barely. This is a real-time subscription, which is it's a very powerful feature that leveraging Hasura and the understanding that we now have of the toolings that it works with, we get an idea as to how something like this can be done without a lot of brain drain on somebody like me, who primarily likes to work in the front end. So let's get back to the slideshow and wrap this bad boy up. You can find it. There we go. We're in the home stretch. Congratulations. We've now reached the entire tech stack: TypeScript, React, GraphQL, Next, and Hasura. Again, there will not be a test, but Hasura is a GraphQL engine that sits atop a Postgres database, generates a GraphQL API, and leverages resolvers and creates custom SQL queries to be performed against your database so that you don't have to worry about it. Real time, so you can, of course, go in and do what you need to. But for a lot of modern web apps, you're doing the same thing. And there was a need and an opportunity to abstract a lot of that boilerplate from developers who didn't need to reinvent the wheel and potentially shoot themselves in the foot. Real-time subscriptions and tight TypeScript integration are also big benefits of Hasura. So we've talked a lot about the past. We've talked a lot about the current. Well, what do I see in the web's future? Well, if you would have asked me this 5 years ago, this would have been my answer then. It's my answer now. WebAssembly. What does it do? It converts existing languages like C, C++, Rust, Python, Go, name a language, converts it into low-level bytecode that can be run in the browser. Think about that for a second. Think about website to web app. And now imagine a world where these languages are run natively in a browser. What does that look like? I also see HTMX, the de-JavaScripting of the web. Is HTML over the wire. Anytime you send HTML, an update to a dynamic web page, not sending HTML, you are sending JSON, which is then interpreted into HTML on the front end. It is a language both the front end and back end can speak, but it's an intermediary language that really would be great if we didn't need. And HTML over the wire is something HTMX brings. It also brings server-side rendering and asynchronous connections directly to HTML. I also see decentralization being a major part of the web. I see the federated web, autonomous but interoperable servers, communities, all agreeing on the same protocols, all being able to interact with one another, but as independent communities without a centralized authority. I see that becoming very powerful. I see us leveraging blockchain. A time-stamped database is not just good for scam coins. Elon 420 smoke coin, bro. No, you have so much opportunity to be provided by blockchain. An interplanetary file system, a peer-to-peer file system that can compete with services like S3. Why give Amazon all the money when we can leverage things like blockchain and peer-to-peer networks so that we pay for file hosting, but it goes to other individuals? So what's the takeaway from all this? We've learned a lot. We've come a long way in 50 minutes. I've struggled with this myself. What I wanted to convey was my personal trajectory on this thing we call technology. The story of JavaScript very much represents my story with tech up to this point. I've used C#, I've used Java, I've written a number of apps, and I'm so sorry to say ActionScript way back in the day. We are technologists. And the only guarantee that we can say is that technology will continue to change so long as capitalism continues to benefit from it. And I believe that will be a steady thing. We stand right now in an age where AI is about, or rather will continue to inject all of these already rapidly changing worlds. JavaScript is just my rocket ship. We need to stay diligent, keep our ear to the ground. We also need to be open to change. How did I learn to tolerate the back end? I didn't let go of my rocket ship when it took me places I didn't necessarily want to go. And I made sure that I was open to opportunities that I didn't necessarily know I should be looking for. Not all dynamics are as dynamic, not all languages are as dynamic and as exploratory as JavaScript has been. But technology as a whole is, and we are heading into a new age. And the one we just came out of, as this talk has shown, was wild. So whatever your rocket ship may be, this has been mine. And I hope that the complexity of the modern web was interesting and that you've enjoyed this talk. My name is Jared Money. I'm a software consultant here at Solution Street, and I appreciate your time today. Thank
you. Anybody have questions? Yeah, anybody online have questions? Thank you, Jared.
Thanks, Jared. Thank you, Jared.
Absolutely. Thank you all.